everyone, Mr. Aaron's. I got a haircut. You saw it for a second there. There we go. All right, today we're on to our second day of the distributive property. We did this last Friday. We're going to do a little bit more of it. Hopefully clear some things up for today and get you crushing distributive property. So the first thing I want to do is I want to review a little bit from what we did on Friday. The first one, we're looking at this, 9 times 199. We're going to practice using this mental math. I know 199 is really close to a number that I can multiply easily, which is 200. So I'm going to rewrite this as 9 times 200 minus 1. Now notice those are the same things. 200 minus 1 in parentheses is 199. And if we remember our rules from Friday, I can rewrite this once again as 9 times 200 minus 9 times negative 1. So what we want to do right here is we want to start with our first part. We're doing 9 times 200. 9 times 2, I know, is 18. I can add those zeros. Minus, and I actually did this wrong. This should not be a negative 1 right here. It should be a positive 1 because we're just doing 9 minus 9 times 1. So that should be a positive 1. My mistake. 9 times 200, we decided is 1,800. 9 times 1, as you know, is 9. That's some easy math right there. Should be something like that. And that would be our final answer. A little bit of mental math. Probably don't know this off the top of your head, but you can probably solve that one. Looking at the next one, we want to make this simpler. I have 10 times 12 plus 10 times 10. I know I can rewrite that as 10 times 12 plus 10. And I can rewrite that as 10 times 22. See what I did there? I took these, connected them, did the reverse of what we did in our first one, connected them back together, and then add them up. So that's a little bit of what we did on Friday. Today we're going to be using a little bit of models, and then we're going to try a little bit of just classical distributive property. So the first example I want to look at is with models here. I think this will be an idea that'll make a lot of sense for some of you. If you don't like it, that's okay, but I think it does kind of link some parts together that we might be missing here. So we're looking at 3 times 2x plus 5. Now over here I made a little model. As you can see, I started drawing it already. And I said that triangle equals x, circle equals, I should say 1. So what I did is I did 3 times 2x plus 5. So I have 2 x's in each one and plus 5 1s. So these represent my 5 1s. These represent my 2 x's. I did that 3 times because we're multiplying by 3. So as you can see here, I have 2x plus 5 once, 2x plus 5 twice, 2x plus 5 3 times. I reorganized, put all my x's together, put all my 1s together, and it becomes what? It becomes 6x plus 15. And it's that easy. That's our simplification of that. We reorganized, we drew it out. I know we had to do 3 times 2x plus 5. Drew it out, reorganized like this. All right, taking a look at our next one. I have 4 times 2x minus 3. Last time I had plus 3, this time I have minus 3. So what I'm going to do is I'm going to make my diagram again. I'm going to have triangles equals x. Circles this time are going to equal minus 1 because I know I am subtracting. So they're going to be minus instead of positive like they were before. So I'm going to start drawing my diagram. I know each one has 2 x's because I have 2x and minus 3, so 3 circles. And I'm going to have to do this how many times? Last time I did it 3 times. I cannot do it 3 times again because this time I have 4 of them. So I drew out my original, and then we're going to reorganize, regroup. I got 1, 2, 3, 4, 5, 6, 7, 8 x's. Those are kind of bad triangles. And 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Can reorganize, count that up. I got 8x plus, oh, oops, don't listen to me there. 8x minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be your final answer there. So although it takes a little longer, it is a method that you can see makes sense if you put it together. We're going to do one more example here. Don't get fooled by this right here. We have it on the back side. Doesn't make a difference to us. Means the same thing. I'm going to write my model again here. Triangle equals x. Circle equals, this time, positive 1 because we're adding here instead of subtracting like we were on the last one. So I got 1x, 2x, 3x, and 1. And I'm going to do this 2 times because I got my 2 sitting over here. Usually it's over there. Doesn't really matter. Doesn't make a difference to me. And I regroup, make this 1, 2, 3, 4, 5, 6. 1, 2, 6x plus 2. Awesome. Those models can come in handy. If you like those, keep using those. Keep rocking them. I think they're a great way to practice this, get some ideas down, and once you're ready to the next step, we'll move on to that right now. This is the traditional method. Traditional way of solving the distributive property. So if you notice right here, my first one, we have -5 times 4x minus 3. We practiced this a little bit last Friday, but when we're distributing, this is what I think of as distributing. Whenever I hear distributive property, this is what comes to my head. Distributing this -5 out to all of my parts. So what I'm going to do first, -5 times 4x. -5 is touching this, so I know it's going to be times. So I'm going to do -5 times 4x. I have a negative times a positive. I know the answer is always going to be negative because their signs are different. Remember, different signs is negative. Same sign is positive. So -5 times 4x is going to be negative 20x. I just did that by doing 5 times 4 is 20. Have that x, attach it on. When we're multiplying, we can do that. If we were adding, we could not. So we got -20x, and then I'm going to distribute this -5 to the -3. So I can either write this as -5 plus -5 times -3 would be positive, because of the same sign, 15. You could also write this, if you didn't want this to be a -3, you could do this, and you could write -20x minus -15. And those would be the same thing. As you know, I like to simplify it like this, make it a little simpler for me. Whatever works best for you is what you should do. So we're thinking about distributing, tossing it out there. Now don't get fooled up. We have it on the back side here, but that doesn't make a difference. We distribute just the same way. So we always distribute to the front side first. So we're going 7 times 2x. They're same sign, so it's going to be positive. I know 7 times 2 is 14. Add that x. Plus 7 times 5, 35. See what we're doing there? We're distributing to the first, then distribute to the back, then reorganize. 7 times 2x plus 7 times 5. We're just kind of doing reverse of what we have been doing. And that's your final answer right there. Quick 2 steps. All right, here we go again. Distribute that out. I love to see those lines when you're distributing. 2 times 7, their same sign, is 14 once again. 2 times -3d, it's positive times a negative. I know it's going to be -6d. That d stays attached when we're multiplying. So 2 times 3d would be 6d. 2 times -3d, it's going to be -6d. All right, we got 2 more examples here. We're on the back side again. We got double parentheses. Don't let it fool you. Distribute these out. We got 3 times 6m. We know the m stays attached. 3 times 6 is 18m plus 3 times 1. It's going to be 3. Just like that, there's your final answer. We're working on that distributing. We got a few more here. Negative 3 times 5, different signs. It's going to be a negative. Negative 15t. Negative 3 times negative 2 is going to be a positive. Plus, negative 3 times 2 is 6. There's your answer. Those are all great examples of distributing right there. Remember, we use those models. We'll get some practice with that today. And that's your distributive property. Nice job, everyone.